Welcome folks. Before us we have a question in physics and transformers. The question reads, figure 8.1 shows a transformer which has a primary coil of 500 turns and a secondary coil of 25 turns. So a transformer is just an electrical device which converts voltage from high to low and vice versa. Now, if you look at this transformer, we have two coils. There is the primary coil, which is this part. And whatever information that you have under the primary coil is considered to be the input. Then this side is where the secondary coil is. This is where we have the output. Right, so the input is the voltage or current that you are trying to transform. Then the output is just the result. Now, let's have a look at the first question. So the first question is all about we calculate the secondary voltage of the primary coil if connected to. So this time is you are given the input voltage, but the question is to find the output voltage. So how can we find this answer? So we are going to say primary. So we'll begin with primary. Then we'll have our secondary. So let's look at the number of turns. So the number of turns for the primary, we have 500 turns. Then on the secondary, we have 25. Now, we need to find the number that was divided by 500 to give us 25. So how can we find this number? So this number is 20. Now, where is this 20 coming from? So you get the one from the primary, you divide with the one from the secondary. So 500 divided by 25 will give you 20. So that is where the 20 is coming from. So which means that any number from the primary divided by 20 will give you the output number. Now, what is our voltage? So the voltage is 240. So if we can divide 240 by 20, then we'll be able to have the output voltage. So 240 divided by 20 will give you 20 volts. So this is our final answer. Then another way in which we can do this is we do the same. We write the primary, then we'll have the secondary. So we have 500, then 25. We have 240, then we put x and we cross multiply. So we form the equation and solve for x. So 500 times x is 500x. Then this will give us 240 times 25. We divide by 500 and also here by 500. So if we cancel, we have x is equal to, cancel this 0. 25 into 25 is 1. 25 into 50 is 2. 2 into 24, we still get the same value of 12. Or if you want, you can use the formula. So the formula is just simple. It's the number of turns on the primary coil divided by the number of turns on the secondary coil must be equal to voltage on the primary over voltage on the secondary. Number of turns on the primary, 500. Then on the secondary, we have 25. So we can now substitute. So we have 500 over 25 is equal to voltage on the primary coil is this number 240, then over voltage on the secondary we cross multiply. So 500 multiplied by Vs is 500 Vs, then 25 will be multiplied by 240. If you want, you can just find the actual number, or if you want, you can just leave the numbers the way they are. So if we divide So 25 here is 1, 25 here is 2, 2 into 240, we'll get the same value of 12. Now for the last question, we are just dealing with the efficiency. So the efficiency, we want to know how much of energy was useful and which energy was wasted. So the efficiency formula is equal to power output, power input. Then you multiply the result by 100. So the formula for power, or before we look at the formula, is a power output. So the output is secondary, so I'll put S, over power input, the input is primary, so I'll put P multiplied by 100%. Then the power is equal to VI. So on top, we are going to have VSC, which is the secondary, times the IS, over VP times the IP multiplied by 100%. Then we continue. Now voltage on the secondary is 12 times the current on the secondary is 8 over voltage on the primary is 240, then current on the primary is 0.6 multiplied by 100%. Then 12 multiplied by 80 will give us 96 over 240 divided by 0.6 will give us 144 multiplied by 100%. 96 divided by 144 will give us 0.6666. So let's say 7 times 100%, which is our final answer is 66.7%. So 66.7% of energy was useful, and if we subtract 66.7 from 100, we get 33. So 33.3% of energy was wasted. So this is how you can deal with the calculations on a transformer under physics. So that's it for this video. Thanks for watching.